Let's talk a little bit about how pressure is measured. We talked about the barometer in Honors Chem. It measures the pressure of the atmosphere. And what a barometer originally was this pool of mercury. Mercury is very, very dense. Pool of mercury. There's this tube, and there's mercury that can rise in the tube, and the pressure from the atmosphere pushes down on this surface of this mercury in the tube, and depending on how much pressure there is in the atmosphere, it will push either more or less mercury up the tube. And the distance that mercury rises is expressed typically in millimeters. And so the pressure is simply a measure of the height that the mercury goes up. Manometer is used, or has been used in the past, to measure the pressure of a gas. It works similar to the barometer. Here I have a vessel where I have a gas in here. Usually a gas is being created in a vessel, and this gas can move and exert pressure, again, on a column of mercury that's in this U-tube. At the same time, the gas is exerting pressure in this direction. The pressure from the atmosphere is pushing down on the mercury, and it's kind of a battle. Let's see who has the higher, can push the mercury higher. And so we usually assume 760 millimeters of mercury, the pressure in the atmosphere, plus the height, if it's 760 or whatever it is, plus the height difference. And you got to think about which one has higher pressure, and you got to know whether you're subtracting or adding the pressure from the manometer. So in this case, the gas is pushing the level of the mercury higher up than the atmosphere can push the mercury. So let's take a look at how we solve a problem here. Okay, on a certain day, the barometer in a laboratory indicates 764.7 torr. A sample of gas is placed in a flask attached to an open-end mercury manometer, shown in this diagram. A meter stick is used to measure the height of the mercury above the bottom of the manometer. The level of mercury in the open-end arm of the manometer has a height of 136.4. 136.4 here, where the mercury in the arm that is in contact with the gas has a height of 103.8. And these are both millimeters. What is the pressure of the gas? So the pressure of the gas is going to be whatever the pressure of the atmosphere is adjusted for this difference. So the difference here between 136.4, let me see, 136.4 minus 103.8 is 33.4 millimeters. So that's an adjustment to the room pressure, and in this case the gas again is pushing the mercury up higher than the atmosphere is, so we're going to add that to the pressure in the room, 33.4, and when we do that we get 798.1 torr. Once